All right, welcome back. So as you remember, in the last episode, we had the issue where it would switch on, but at full speed, we'd get really weird results. And I can see what these are. These are the memory check addresses, and then this is just the counter that I have to count up from 0. So if I turn this off and turn it back on, you can see where it almost says memory check, like memory, there's the, and then it's going in random places. So it almost seems like there's something wrong with the address that is going out, because it's putting it in the wrong place, but it's putting it in the same order. And you'll see it again here. I've noticed this several times this week. So there's the M. Let me get it again, and let's see if we can get another. See, there's EC, like ECK for check. So I don't really know what's wrong. Right now I'm running it at 1 megahertz. I could switch it to the slow clock and we can sit here and just watch it go, but we all know how that turns out since we saw that last time. So what I'm going to do is I'm going to hook this up to the Arduino. The Arduino. And just see what's coming out of the address and the data pins. And when I ordered the backplane and the cards, I also made this little breakout board. Basically, it's just the 40 pins here that get plugged into the backplane, and I can either pull it out on a 20x2 cable, or I have the data and the address lines right here, so I can hook them up with DuPont cables. And so what I'm going to do is I'm going to plug this in to this header that I soldered on here, and I'm going to run it into the Arduino, and we'll do some programming and see exactly what's coming out here, if it's what we expect or if it's I don't know. We'll see what's happening. It looks like it's following logic, but again, who really knows? So yeah, let me get this plugged up, and then we'll get to troubleshooting. Okay, so I've got the Arduino hooked up to the data and address, and I use the clock to as an interrupt to gather what's on the data and the address bus. I've got the ground hooked up here. I've got the clock hooked up to pin 2, and then the address hooked up there, and the data hooked up there. So I'm going to turn it on and then just see what spits out, and we'll take a look at that and see if we can analyze and see what's coming out of the data and address buses, see if there's something wrong there. Oh, okay, but if you notice on the display, okay, now I'm really confused because this is working. So you notice how it's just counting up. That's all it's designed to do. And yes, the numbers over here are blurry because it's happening so fast. Everything else looks fine. Let me try that again. Yeah, it's doing its memory check. I'm really confused because that's working. Okay, hold on a minute. Let me turn this off. Let's go back to the original state. Unplug this. Now let's turn this back on and see exactly. Yeah, see? All right, we'll try it again. All right, let me plug this back in. Okay. And that's working. Huh. All I have hooked up here is the clock, the address, and the data buses. What if... Oh. All these pins... I need to take a look at this. Hold on one second. The digital pins on the Arduino, I believe, all have pull-down resistors. What if this is just an issue with the bus? Although I'm really confused as to why this would happen here, but not on the breadboard itself. I wonder if there's an issue with one of these cards. I can't really test without one of them, so that sucks. I wonder if there's something causing a data or address pin to float rather than go either a high or low. So let me, yeah, let's do an experiment here. What I'm going to do is I'm going to disconnect the Arduino. I don't think we need that since it works with it. I'm going to actually take these lines and hook them up to some resistor arrays so that we can, 10K resistor arrays so we can pull it low, and then try this again and see what happens. I'm a little concerned about that because I don't know what's causing it. I'm going to have to look into these cards just a bit more and see if there's something that could cause one of these pins to float. But again, I'm really confused because this didn't happen on the breadboard. And I wonder if there's something to do with the capacitance of the breadboard or something similar. Obviously, I'm not an electronics engineer. Electrical engineer. So I don't really have that deep understanding of how electricity reacts in different areas. So let me, I'm going to look at these cards and see if there's anything that I see that's strange, which I've already done several times and I don't. But let me hook up the resistor arrays to this and see if it fixes the problem. I am going to go through the program. Well, I don't really have to go through it. Pony80's already done that, and he did a good job of going through the Arduino program to show what's on the pins. I may show the code just to so you don't, so you'll know and you'll see exactly what I do when I use this. But Pony80's got a really good video on debugging with the Arduino. I'd encourage everybody to check out his channel and take a look. So let me pull this apart and go get a breadboard and put some resistor arrays on it and then plug these into it and see what we can do. Okay, so here I've got a little breadboard and all I've got is some resistor arrays on it, and they're 10K resistor arrays. And what resistor arrays are is, let me pull this out here and kind of demonstrate. This has 9 legs on it. 8 of those legs are connected to resistors, and all of those resistors are connected to this 9th pin right here, which is the ground. So it's a really convenient, space-saving way to use the resistor. And if I plug this in here, just like that, we actually have 3 sets of 8 pins that can be used. So 24 pins, which is the 8 for the data and the 16 for the address. And all I have to do is plug all that in and connect the ground, and we should be good to go. So let me go ahead and do that, and stay tuned. We'll see what happens. I'm really intrigued here. This is interesting, but I'm afraid that this is showing a this is going to, I don't want to say camouflage. That's not the real word I'm looking for, but this is going to kind of hide the real issue. This may fix it and it may work, but we need to drill down and just see really what this problem is. And as a software developer, that is definitely one of the things that you always have to be aware of is, am I fixing the problem or am I just camouflaging the problem? Because if you're just camouflaging it, chances are later on it's going to come back and bite you. And I've been bitten more than once. So yeah, let me get these plugged in here. Almost done. So here we go. All right. So I got those plugged in there. Make sure none of them are plugged in directly to the ground. They're not. Good. They're all going through the resistors. All right. Now here is the display. Let's see what happens. Huh. All right. So that's working fine, it looks like. We don't see any of the weirdness that we saw. And this code that I've got running, basically I've just got 3 registers, HL, BC, and DE. And I'm counting up from 0 to 1. And each time one of them increments, or one of them hits the max and rolls over, I increment the next one. So we could literally count to, I don't know, 2 of these would be over 2 billion. I don't know what 3 of them would be. I'm really not really good with 6 byte. What would 6 bytes be? 255 to the 6th power, whatever that is. Anyways, so it's working. Yes, it's a little blurry on the end there, but that's to be expected. I mean, LCDs can only react so quickly. Actually, let's do something really interesting just to see. That's a 1 megahertz clock oscillator. Yeah, 1 megahertz. Let's pull out the 10 megahertz oscillator. And just for fun, and here I am on pseudo live TV testing stuff out and going off script, which is always a great thing to do. And turn it on. And it's still working, even at 10 megahertz. Of course, like I said, I agree the numbers are blurry and you really can't see what those say. And if I was displaying text, like if I was reading from the web and trying to just display a bunch of text there, it would be useless. But for this purpose, it works well. So we've had to ground all of the data and address pins, and I'll probably maybe here in a few minutes just experiment with removing some of these to see if it's one or the other. But I also want to take a deeper look at the cards and see if one of them could be causing a floating address or data pin, and get that fixed up. So anyways, I didn't even have the ground plugged in. Okay, that's interesting. I did not have the ground plugged in, so somehow just running these into the resistors and having almost a termination on the bus. Now I'm really confused. So yeah. So we'll keep looking into this and we'll see what it is. Right now it's working. I hate to say I'm going to move forward, but really what I'm going to do is keep working with this and keep seeing if we can figure out exactly what the issue is, because this didn't happen on the breadboard. That's the thing that keeps sticking in the back of my head, is it didn't happen in the breadboard. So anyways. All right, so it looks like I may need to build in some pull-down resistors into, I would probably say, the CPU module. We'll see exactly. We probably need to build it into one of the cards. The CPU module probably makes the most sense. But like I said, also, I'm really leery that we're covering up a problem and not solving a problem. So that's always something to be cognizant of. So, all right. Next video, I'm going to start talking about interrupts. The Z80 has some really good interrupts. They got 3 modes of interrupts. They've got a non-maskable interrupt, and they all work just a little different. And I'm going to go through the non-maskable and all three modes of the regular interrupt. Obviously, I'll give you some heads up. So the mode 0, it works just like the Intel 8088, or is it 8080? One of those two, that it was replacing. And the reason why they did that, it was so that they had that market backward compatibility, and they could just use the Z80 the same way. It's the same thing with the instruction set. The Z80 is backward compatible to the 8080, so or 8008. It's one of those 8 numbers. There's 8s and 0s in there somewhere. It is backwards compatible, and that's what mode 0 was for. So mode 1 is where it just calls a static address and operates from there. But mode 2, which is the where the Z80 really gained popularity, is the interrupting module, or the interrupting hardware actually placed an 8-byte address on the bus, and it would take that and what's in the I register, and it would jump to another place. And so it gave a lot of flexibility with the interrupts. But we'll talk about all that in the next video, and I'll go through some examples. Of course, I'll have some more hardware, because the next module we want to develop is the timer module, which will give us, I don't want to say a real-time clock, but it'll give us a consistent clock no matter what the oscillator speed is for the CPU module. So we could be running at 10 megahertz at 1 megahertz, and this timer module will count consistently because it has its own oscillator. That's helpful because we can do delays and stuff like that. We can do some timing stuff. And if you're familiar, like with the old Commodore 64, you had the number of ticks. What was it called? It was the not ticks. Maybe it was ticks. But you had the number of ticks since it powered up, which would allow you to be able to pseudo tell time if you set the time when you turn the machine on. So that's a bit what I'm going to be talking about in the next video. I probably gave too much away, but tune in here, and we'll discuss that. And as always, appreciate all the comments. I really do. I read them all. I try to respond to them all. And I appreciate the likes and the subscriptions, and anybody that's sharing this. Thank you very much. I'm not doing this for any big, I'm not a corporation. I'm one guy. I've got a day job, and I usually do this at night. And it's a lot of fun to experiment, and it's a lot of fun to hear the comments of people enjoying this or learning from it. I never considered myself a teacher, but you guys have made me feel really great, and I appreciate it so much. Guys and gals, I guess I shouldn't say that. It's something I've always tried not to say, but I found myself just saying it, so I apologize. You folks have made me feel really appreciated. I've got a lot of good comments. I've gotten some feedback. And if, again, whether it's good or bad feedback, as long as it's constructive, I'm great with that. I will take it, and I will learn, and I'll move forward. So anyways, I'm going to look more into these boards and see if I can figure out what's causing the issue. But until then, we've got a semi-solution, and then we'll go, like I said, in the next video into interrupts. So, all right, so here we have the Arduino program that I wrote, and I've got the address pins right here. I've got the data pins right here, and they correspond to the pins that I plugged the address and the data buses into. I also added clock again as an interrupt. If you look down here, attach interrupt of the clock on the falling side of the clock. So these I'm not using right now. I coded them in, but then when I started testing, I found out that just hooking it up to the Arduino solved the problem. Sorry, camouflaged the problem. So I'm not going to be able to really demonstrate those right now, or I will demonstrate them later. So just hang tight. So basically, when on clock happens, which is when the falling side of the clock signal happens, this runs and it puts out all of the address pins plus all the data pins, and then it prints everything out. So let me go ahead and turn on the Pony80, and we can watch what happens here. So ignore the read-write, memrec, and IRQ, but you see all of this right here. And if I turn off the Pony80 and scroll back up and go up to the top, you'll see where we start at memory address, probably this one right here, 00. All the rest are just some garbage when it turned on. But there's the address, the data, and then, like I said, I really need to hook up the read, write, memrec, and IRQ to show you. But I can basically get everything that I need to get to troubleshoot from here. So this program is really it's invaluable to troubleshooting the what's happening on the bus and where it's going. Of course, I didn't even get to use it. I hate it because I sat down and I wrote this one night and had it all set up so that I could use it to figure out what was wrong with the Pony80, and it wound up not even being a problem with the program or the bus or anything like that. It was just floating pins, or it seems to be. I'm still at a loss as to how to troubleshoot this. So going forward, like I said, I'm going to look at the individual cards and see if there's anything that would leave the pins floating. But like I said, this is all based on Ben Eater's video, which I'll post a link to, probably right up here. And if you, you know, big shout out to Ben, because he got me into this whole electronic stuff. I mean, I've been enamored with electronics my entire life, but I never knew how to use it until I saw his videos. And that, so please go visit his channel, give him a subscription, give him a like, comment. I actually built his whole breadboard CPU computer, and that's really what led me on this path here. I went Z80, he went 6502. No hard feelings. I ordered Z80 because that happened to be available, and I was reading an article about it. So again, very live and let live and go with the flow. But anyways, enjoy. Hope you guys got a little bit of knowledge from this, and if not, I'm sure you'll leave a comment. If you like it, leave a comment, subscribe, whatever. I'm kind of easy, so anyways, until next time, talk to you later.